Hello, we're Group 57, and we would like to begin by demonstrating that our program compiles. As you can see, there are no errors or warnings. We will now move on to running the program on supplied test cases.
Audio files for dual and short, along with the given output files. We will run our program on each of the following audio files and use the cmp-l command to verify that our output matches the audio results provided. Now that you see our program works, let's do a code overview and go over the key parts of our code.
The program add echo is to add an echo effect to a wave audio file. It reads a source wave file, modifies its header to accommodate the echo effect, then mixes the original audio with an echo and writes the result to a destination wave file. We have to split up the task of add echo into 3 functions: copy and modify header, mix echo, and main. Let's start by taking a look at copy and modify header function. This function is responsible for reading and updating the header of the source wave file. First, we use a character buffer called header to store the first 44 bytes of the audio file. Then, we copy the data in the header responsible for the size of our audio file. We need to accommodate for the echo effect, which increases the size of the audio. So we add delay times bytes per sample to each one. Then we update the header with the newly calculated values. We make sure to reposition our destination file offset using lseek to the start of the file, and we write the contents of our header into our destination wave file.
Let's examine the mix echo function. This function implements the echo effect by reading samples from the source wave file, mixing them with the corresponding delayed samples, and writing the mixed samples to the destination wave file. We start by allocating memory for the echo buffer. We dynamically allocate memory to hold delay samples, a number of short integers, using malloc. Then we make sure that the memory allocation is successful. If not, we print an error message, and we exit the program. Next, we initialize the echo buffer with zeros representing the initial state of the echo. The audio samples are then read from the source file, source FD, in a loop until there are no more samples left to read. Then for each audio sample read from the source, we calculate the corresponding echo sample from the echo buffer, scale it by the volume scale factor, and add it to the original sample. The resulting mixed sample is written to the destination file, dest.fd. The echo buffer gets updated with the current sample read from the source, replacing the oldest sample in the buffer. When we reach the end of the original audio file and have read all original samples, we write the remaining echo samples from the echo buffer to the destination file. This ensures that the echo continues beyond the end of the original audio. Finally, we free the dynamically allocated memory from the echo buffer to prevent the memory leaks.
Let's go through the main function. First, we initialize a volume delay and the volume scale with default volume 8000 and 4 respectively. We then check the number of command line arguments. If we receive an unexpected number of arguments, we print an error and terminate the code. If no issue are found, we loop through command line argument to find optional parameters -d for delay and -v for volume scale. If found, we update the corresponding variable accordingly. Next, we extract the source and destination file name from the command line arguments and check to make sure that both source and destination files have wave extensions. If not, the code points an error message and exists. We then check the source wave file in read-only mode and create the destination wave file in read-write mode. If it fails, points an error message, close the source file, and exists. If any issue arises, we print error message accordingly. Next, we call the helper method we discussed earlier to populate the destination audio file with the correct bytes of data. We first call the copy and modify header function to copy the header from the source file to the destination file and adjust it based on the delay. Then we move from the header using the seekl function to begin writing more audio data. Next, we call the mix echo function to apply the echo effort to the audio data read from the source file and read the result to the destination file. Finally, we close both the source and destination files to release system resources and return 0 to indicate the successful execution of the program. With this in mind, we now demonstrate the testing we did on our code.
To holistically test our program's functionality, we created two wave audio files similar to the short wave file and compared the results to our expected numbers. As we can see, when we compare the bytes, our expected result and the output audio are exactly the same, as expected. As well, we took into account various ways that our code could crash. For example, we started by considering invalid inputs by the user. Let's take a look at the case where a user enters an incorrect source file name. The file either does not exist altogether or has an unsupported file format such as MP4. In both cases, we raised an error and terminated our program. A user could also enter negative integer values for the volume scale and delay. These values do not make sense, so we print an error to the user. A user could also miss the -d specifier. In this case, we want to make sure that the correct values are being used for the echo. Specifically, the volume scale should be defaulted to 4, and everything should still compile. We also considered possible edge cases that include a delay or volume scale of value 0. Then the code raises an error because if the delay is 0, it simply increases the sound of volume. And that's not the job of our add echo program. If the volume is 0, then no echo will be produced altogether, defeating the purpose of our code, so we raise an error. Another possible edge case is an audio file of size 0, which produces an empty audio file. If we compare the bytes, we see that at byte number 5, the size has increased, which makes sense because we added an echo to the audio file, and at byte 41, there's a difference in 6 bytes, which also makes sense because our delay is 3, and the volume scale is 2. 3 times 2 is 6. We made sure to split up the work among ourselves so that we all had a chance to contribute to the project. For the addecho.c program, I, Anna, wrote the main function.
I, Eric, wrote the mix echo function.
And I, Liu, write the copy and modify header function.
For the remove vocals, I wrote the initial code, which had several warnings. I handed off the draft to Eric and Liu, who made corrections to my code and added error checks for certain edge cases. We hope you enjoyed our presentation.
Our output file bytes match the bytes of the desired output files. We also want to demonstrate that our output wave files have an audible echo. I will compile our code on the DAW audio file and play it to show you the echo. And for the second one,